Negative 1/2? So that you got negative 1/2 to work? Somebody? Yes? So number 30. Wait, no. Okay. Let's do this. Number 30. There's 5. All right, good. Makes me feel better. Number 30 in section 5.5. What is the list? Let's just do this real quick. Can somebody create the list of possible things to try for number 30?
Is positive, negative 1, 2, 3, 6.
Good, because that's all the factors is 6.
Yep. And the bottom is positive, negative 1, 3.
Okay, cool. So you got 1, 2, 3, 6. And then let's see, 1/3, 2/3. And that's it. Because 3/3 and 6/3 are there already. And Descartes doesn't really help us. Thanks a lot, Descartes. Right?
Okay. Negative 2/3.
Negative 2/3 worked?
Yeah.
Okay. So try negative 2/3. It's definitely one of the possibilities, right? Okay. So again, in the homework, sometimes the list can't be, decreased a bit. If I was facing this, I would try to do 2 or 3, because maybe it's going to be an upper or a lower bound if I do negative 2 or negative 3, right? You always have the bounds that can come into play and can cut some stuff out of the list. Are you guys with me? Anytime you try something and it doesn't work, take a second and make sure it's not a bound, because maybe it's giving you more information. Does that make sense? So if I was trying this problem, I would try 2 or 3 first, because it's somewhere in the middle. But somebody told us that, so for this problem, a possible hint is negative 2/3. Somebody says they got that to work. Does it look like it works? Good, okay. Yes? 57 where? Okay. Oh, so this one just says, I really want you guys to understand, this one just says list all the possible zeros, rational zeros, right? It doesn't want you to actually divide it. You see that? It just wants the list. Once you set up the list like we just did here, once you set that up, you're done. So I don't know if you tried to divide it, or did you have trouble making the list?
Yes.
Which one was it again? I'm sorry, 57?
Yeah.
Okay, let's do 58, just because. What would go on the top of my list? As I start to make my list, what goes on the top? What always goes on the top of my list of possible rational roots? No. Sure. In general, what always goes on the top? What number am I looking at? What number am I looking at to generate what goes on the top of my list? 4. I love it. Factors of the last dude, yes? Okay. Plus or minus 1? Oh, I'm trying to erase the cursor. 2, 4. What goes on the bottom? Factors of the first dude, right? We talked about why that makes sense. Okay. And then how do I create the list? I just divide, I make all the possible ratios I can. So I'm always going to get one that's just going to be this list because I divide by 1. And then I'm going to do 1/3, 2/3, 4/3, right? Bottom. You do the exact same thing for number 57. Does that make sense? No? Is that? You all right? It's okay if the answer is no. We could do a quick little review of why this is true, but okay. So making the list of possible rational roots has got to be a nice, quick little part of the problem, right? Understanding why it works, we talked about that. So hopefully that makes sense about why we do this. But the how we do it is very straightforward, very recipe-ish. You just kind of construct it the same way every time. And again, this problem does not say solve. It does not say factor. It just says make the list. So you're done when you make the list. Okay. Anything else from homework stuff?
Yeah, number 50.
Same section?
Yeah.
This guy. So one big thing right here I always forget about is they say with the given graph, so just graph this in your graphing calculator, right? Does it say to solve it? Does it say to find the intercepts? Does it say that you have to graph it by hand? No. Does it say you have to factor it? Does it say you have to factor it? No. So again, students, and I'm not saying this is what happened, students will get themselves in trouble because they don't read the instructions. And the instructions say, just do this one thing, and then they try to do the, I'm like, no. These might not even work. This might not even have anything that I can find by hand. Are you guys with me? So, real quick, what does Descartes say? Let's do another problem. Let's do 51 since it's right there. Why is 51 really nice for Descartes? What would he say about this? How do I investigate this in terms of Descartes' rule of signs?
It's got all positive.
Good. So what does that mean? The number of possible positive real roots is what? 0. I don't see any sign changes. And again, why does that make sense? You cannot plug any positive number in there and get 0 out. Because every term is positive, correct? So the lowest number you could possibly get by putting a positive number in is 300. If you put a number right above 0. That's why this makes sense. How do I investigate the number of negative real roots?
You do f of negative x?
Good. Do f of negative x. What's the shortcut? Which terms are going to change sign?
The ones that are odd.
Odd powers, good, because the even powers just eat the sign up, right? So this is going to change sign. This is going to stay the same sign. This is going to change sign. And of course the 300 didn't give a shit what I do with x, because it has no x. Let me stop for a minute. So the neat thing here is, by putting a negative x in, I'm kind of simulating putting all negative numbers in. And then I'm kind of investigating this the same way, yeah.
What if there's only one sign change?
Then there's only one positive real root if I'm looking at the thing, which is kind of nice. Even if Descartes doesn't destroy or doesn't cut our list in half, it will. If there were one positive real root, 2 or 0 negative, I might start with a positive because some guarantee that one of them works. Or if you're a gambler, there's a chance 2 negative roots, so you might try with the negatives. You guys kind of with me. It depends on your personality, right? You're not used to a math problem depending on your personality, but there it is. How many negative real roots are there? How many sign changes are there? 1, 2, 3. So there's 3 or 1. So obviously this one kicks ass, because whatever the list would be, I can cut it in half, because I can throw out all of the what?
All the positives.
I can throw out all the positives. That cuts my list in half, right? And the absolute worst thing about these problems is when I have a giant list of numbers to try. You guys agree?
Yes.
The synthetic division needs to be the easy part of this. When I say that, it's really stupid easy to make a simple mistake in your synthetic division, and that will drive you a little insane. As long as you show me the work, I'll give you most of the credit if I see that you're trying to do the right thing. Does that make sense? Because I am all too well aware, as I've shown evidence throughout this semester, that you can make a really simple little mistake. You'll say 2 times 3 is 5. You'll say negative 4 plus negative 8 is 12. Right? It's just human. Okay. So just show me your work. Anything else from homework stuff. Is that good enough for the person who asked that question?
Sorry, why is it a 3 or 1 negative one?
Yeah. Well, why is there 3? Are you cool with 3? How did we get 0? Are you cool with 0?
Well, that's because it's all positive.
Good. No sign changes is the important thing. So when I look at f of negative x, you do the exact same thing. How many sign changes?
2,
No. 1, 2, 3.
Oh, okay.
And of course, why does it go down by 2? Can you guys tell me? Why is it 3 or 1? Because if it's not real,
Complex roots always come in pairs.
pairs, 11. Because where do they come from? Quadratic formula, and quadratic formula has a plus or minus in it.
This is a 1. Alright.
Where do complex roots come from when you're solving an equation like this? When you get to quadratic formula, right? That's where the complex stuff would come from. Does that make sense?
Yeah.
The quadratic formula has a plus or minus in it.
Yeah.
So if it's not real, it's complex. And if there's a complex answer, there's got to be at least 2 of them.
Plus or
So if it's not, there's either 3 real negative roots, or there's some complex, and they have to show up in pairs. So there's only 1 negative real root. I need this to make sense. Since complex numbers show up in pairs, the number of real roots is always going to go down by 2, because if there isn't a real one, there's a couple of complex ones. They have to show up in pairs. Just because of the plus or minus in the quadratic. It's crazy. Quadratic is always going to give you 2 answers.
Well, so what do we do?
Say again?
What are you saying that quadratic formula always gives us?
So either there are 3 negative real roots, or there's some complex roots, and complex roots have to show up in pairs. So if any of these are not real, there must mean 2 of them are complex, and that's why it's 3 or 1. If there is a complex answer, how many complex answers must there be? Because where do they come from? Where do complex answers come from? Quadratic formula. Okay, how many answers does a quadratic formula always give us?
Plus or minus.
Beautiful. So if there is can there be 1 complex solution? No. There must be 2, because it would come from the quadratic formula's got a plus or minus in it.
Sorry.
Do you agree there are 3 sign changes?
Yes.
Okay, so if it isn't real, it must be imaginary, complex. So either they're all real, and like we just said, could we have 1 complex answer? I'm not sure what to do. So quadratic equation is where complex answers come from. A quadratic equation has a plus or minus in it. Quadratic equation will always give us 2. Complex answers come in pairs. Is everybody with me?
plus and a minus.
If there are 3 possible real roots, but then I figure out one of them isn't real, that must mean 2 of them aren't real, because complex answers always come in pairs. That's it. So for example, if I saw 5 sign changes in a polynomial, right, that would mean there's 5 roots, or 3, or 1 real root. All because if it's not real, it's complex, and complex only show up in pairs.
I wrote down as much as I could.
Say again?
I wrote down as much as I could.
Okay, all right. Anything else from homework stuff?
70.
All right.
No, it's 78.
Same section?
78.
Same section.
Same thing.
This one here, okay. This one here, the one about the radius and the height. This guy? Yeah, okay. So let's see, right circular cylinder. If you look in the section, I think they give this to you, but the formula for the volume of a right circular cylinder. What's the area of the base? Right, it's a circle, so let's say this is R.
Pi r squared.
Good, pi r squared. And if this is H, think of this as Do you guys remember CDs?
Yeah.
All right, so if you stack a bunch of CDs up, if I knew the area of one CD and how many CDs are stacked up, I could tell the volume that goes through. So if I know the area of a shape and it's a repeated shape, the volume is just going to be the area of the base times how many are stacked up times the height. I like it. I'm pretty sure they either give it to you in the section or it's in this book somewhere, but this is the volume of a right circular cylinder. Notice how there's two variables, right, that control the volume. You with me? So the radius and the height differ by 1 meter. How do you write that?
R plus one.
Sure, okay, the height you could say is r plus 1, sure. Radius is larger, it says though, so be careful. They do give me a little extra information. Radius is larger, so if they differ by 1 and the radius is larger,
Oh.
the radius is h plus 1. Wouldn't they be off by 1 and wouldn't the radius be bigger? Okay. So the beautiful thing here is if you just plug that in here, then you'll get something. And be careful. Let me see if they say this here. What are they trying? Oh, okay. Weehaw. Oh, that's all I wanted. That's silly. Oh, the volume is 48 pi, right? So volume is pi r squared h. I know this is 48 pi. Is that cool? And I know, I know r is what? What do I know r is?
H plus one.
H plus 1, yeah.
Yeah.
Really nice thing is, if I'm going to synthetically divide, the last thing I want to see is pi. That's freaky. What happens with the pi's? Cancel. Okay. So you are going to FOIL, distribute, subtract 48. You're going to end up with something you have to synthetically divide. So that's the purpose of this section, of course, is making a list of possible answers and then synthetically dividing. This is a word problem that ends up with a synthetic division problem, right? Okay, maybe. Oh, let me see here. Let me catch up real quick. Who came in, didn't get their stuff back? Oh, man. Hey. What's your name again? Huh? Oh. I have stuff for you somewhere. Oh, here it is. For one thing. Who else didn't get the stuff? List. A lot of information. Yeah. What is true about 5-7?
No, are we on that side?
Actually, I can go here. Do. So we're about to get into chapter 6. 5-7, I made extra credit, right? Okay. All right, guys, let's do that. Let's get into chapter 6. If there's no other questions from chapter 5. Okay. So let me say this real quick. Actually, I'm going to do it all up here, so it's good. So again, if you're not where you want to be, I'm not sure how many times I can say this. I've got office hours. If those don't work, you can email me and say, these are the times that work for me. I could Zoom with you. I've done that a couple times this semester already. I don't like making Zoom office hours set because I don't like Zoom. But if that is the best way I can help somebody, I will Zoom. I've done that. I will totally do that. You guys kind of with me. If you're like, I don't want to listen to you anymore, Jeff. I get enough of you in class. Great. There's tutors that can help you. They can do online. They can do in person, face to face. Are you with me? They can do drop-in. They can do appointments. It's insane. You with me? Quiz test corrections. Can you get help from people with those? Hell yeah, and if you don't make sense to me. So yes, you can get points back on your quizzes and tests. Holy shit. I wish any of my teachers would have done that for me. So please, dear God, take advantage of that. Right? I hate at the end of the semester, I'm like, if only this person would have done a couple corrections, they might have passed. That has happened so many times. You guys understand? Alright. And then you say, why didn't you pass? Because they didn't make a passing grade. What do you want from me? So if you just do a little bit, and if you make corrections, you'll understand that material better, and when the final comes, you'll do a little better because of that. So it's silly. You get a twofer. You get an immediate boost to your grade, plus you understand the shit better, which means you're going to do better. It's insane. Okay, sorry. So some of you guys are doing that. You're not getting as many corrections right because you're not checking them with me. You're not getting help, so please do that, right? If you're having a lot of trouble with your grade, don't just go, well, FML. No, get help from me, get help from tutors. If the homework is too much and you've got like 3 jobs like I did, come see me. I will tell you, I will cut it down for you, we'll work together so you can get enough practice. The whole point of homework is to give you practice. And if you sit down and go, well, there's too much to even start, well then you're not getting any practice. It doesn't make any sense. Are you guys with me? I like it. All right, so I appreciate you're here. There are still more people enrolled than show up, which, I can only do so much about. So I appreciate that you're here. There are other things you can do. And like I said before, the worst thing is if you feel like you're doing everything you should be doing and you're still not making the grade you want, I desperately need to talk to you. We need to really analyze what you're doing and figure out if there's anything. What really sucks, I don't know if any of you guys realize this, we used to offer a class, Math 110, that was prerequisite stuff for Math 176. I don't know if I talked to you about this, but the state we're not legally allowed to teach that class anymore, which is a whole thing on itself, so I'm not going to go on a rant, I'm sorry. So there have been students who were doing every damn thing they could, but they were not passing, and because they didn't have a grasp of the prerequisite material. In which case, we do have extra stuff you could do to try to catch up with that, but you have to start early. We're almost, what is this, the 6th or 7th week? Once spring break is here, we've gone through the first 8 weeks. We're like halfway through the semester. You guys with me? So that's a lot better than trying to do something in week 12. But again, if you're not where you want to be, we can identify together what more you could do, what it is you're doing that might not be enough, or what it is you're doing that's not really helping. You guys understand? Okay, I'm sorry. Some of you guys are doing everything you can, I love it. Some of you guys are doing okay, that's fantastic. Okay. Yeah.
Can we just quickly go over like the slant?
Yeah, we have to talk about slant. Thank you. That's the last. Well, let's do a couple of examples. Did we finish the, let me see. Yeah, this handout. So much paper. Did I give this handout out? I got a lot of them still. Yeah, I'm pretty sure I gave this out, but I don't know if we finished this. I think we did. Let me show you this. The one that's got the little box about the horizontal asymptotes. Did anybody not get this, that you can easily make out what it is? There it is. Okay. Anybody need this sheet? Okay. Sure. Everybody else is good? So I'm pretty sure, even though I don't know where my copy is, we finished this the other day, yes?
Yes.
Yes. So the only kind of asymptote we haven't talked about yet is this slant asymptote. So I want to do a cool little thing. We'll see if you agree with me that it's cool. I need paper. Here we go. Paper. So can you guys, real quick, let's do this together, just to get this going. Let's see, I've got this here. Okay. Actually, you guys do this. Can you synthetically? What? Let me do this. Let's do this. So I have to do it long division. Let's do this. Make it x squared plus 1 on the bottom. There we go. Can somebody explain to me why you wouldn't want to use synthetic? Well, let's see. Let me do this 2 different levels. Why officially can you not use synthetic division to do this?
Because the bottom term is 2.
Good. It's not linear in the bottom, correct? You could factor the bottom. Does anyone think I'm insane? You could factor the bottom like what? Careful.
X plus 1/2.
Nope.
No, x plus 1/2.
X plus I, x minus I. I love it. You can't do that with real numbers, right? It would have to be x squared minus 1, yes? So we're not going to do this. Don't freak out. There's a couple problems in the homework that make you synthetically divide with complex numbers. I love those problems. I would. We're not going to do that. So you could theoretically use a synthetic division if you wanted to synthetically divide twice with complex numbers. I would much rather just use long division. Does anyone agree with me? And you never thought you would agree with me by saying you want to do long division, but you just did. Okay? Yeah, I love it. I would agree. I don't want to do synthetic with complex twice. All right, so help me out. How do I do this long division?
X is on top.
Yeah, x squared times what is x cubed?
X.
So x times x squared.
Cube.
That's crazy. X times 1
X.
plus x. Line it up with like terms. Is that cool?
No.
Shoot. Then I
Minus it.
change the signs. These cancel. This comes down. Negative 2x minus x is negative 3x. And then I bring the 1 down. Let me stop for a minute. Yes?
Okay, so that's saying like this is, the book shows them putting the quotient above the thing that's like it.
The book shows what now?
Okay, so like if in the quotient you have an x, then they put it in the x's spot. As opposed to like you got it the x
I don't care. Whichever way makes sense, you're going to end up with the same answer. For me, this is what makes sense. Yeah.
Because,
Huh?
why does it?
Because x squared times 1 is x cubed. It kind of lines up better.
Okay,
Yeah, yeah.
okay.
It doesn't matter where you put it, whatever makes sense. So for the book, it made sense to put it somewhere else, which I wouldn't agree with, but they come up with the same answer. Does it make sense? Okay. Oh man, what's the next step here?
Four.
Good. X squared times 4 is 4x squared. So 4 times x squared is 4x squared. 4 times 1 is 4. Line it up with your like terms, right? Change the signs. And I get negative 3x minus 3. Is that cool?
Minus negative 3x minus 3 over x.
Good. Yeah. So you got to be a little careful. I'm going to do this. Negative 3x minus 3 over x squared plus 1.
Let's change that plus.
If you put a minus here, you would take a negative out. These would both become plus. So you got to be a little careful. All right, let me stop for a minute. Is everybody with me so far? Now, some of you guys might be sitting there going, why the shit are we doing this? Because this man just said, we're going to talk about the asymptote. And he's doing long division. He's obviously still off his meds. Will anybody please refill those? The reason I'm doing this is, what situation is this problem in from a historical? I love that. From a horizontal asymptote perspective. right? For horizontal asymptotes, what do I compare to see which situation, which one of the three situations I'm in?
The top and the bottom.
Yeah, the top power is larger than the bottom, correct? So that's the one that it says there's a slant asymptote. So what is the idea of a horizontal asymptote? When do they kick in? When do horizontal asymptotes kick in? When x gets stupid positive or stupid negative big, yes? That's why it's kind of like end behavior. You guys kind of with me. I just figured out an expression that I can now let x get big. And see if I do it to the original, I just get big over not quite as big, so it just goes to infinity. Now I've got a little more detail. Can anyone tell me what happens to this piece if I let x get big? This piece by itself, the remainder is always going to have this happen. What's the degree on the top? Degree on the bottom? 2. So the degree on the bottom is bigger. If I let x get big, it's going to go to 0. Kick-ass, you guys all with me? That will always happen with the remainder because the remainder is always going to be when the thing I'm left with is a smaller degree. Okay. So if I let x get really big, this whole thing basically looks like x plus 4. That's what we just proved. Because this piece of it goes to 0. Okay, maybe. Now, what does that mean graphically? That means that this line is the asymptote. That's why we call it a slant asymptote. X plus 4 would look like, from your perspective, like that. So real quick, if I wanted to graph this thing, this one's a little bit gross. Well, let me do this. I was just going to show you what it looks like in here. Let me see. So everybody got that work there? Okay. Let's go to one of the best little graphing programs around. Now again, if we could, we would teach this class in a computer lab and we would just use Desmos. That'd be amazing, but we don't have enough money for that. But if I'm you and I'm home and I need to graph something, I'm using frickin' Desmos. Let's see, so I'm gonna put this in here. Huh? Didn't know what? All right, I've pulled this up a few times. Let's see. If you highlight all of this and then say divided by, now look at that funky dude. Looks like a weird diagonal heartbeat thing. Do you see how as x gets big, doesn't those look very linear? If I put in here x plus 4, there you go. When x is small, does it look like it's approaching the blue line? No, but as x gets big, is it approaching the blue line? Hell yeah. So the funny thing is, when there is no real ceiling, it's going to go to infinity, but it's going to go to infinity in a very prescribed way. Are you guys at all with me? Now real quick, we're not going to do this long division, but if I had put x plus 1 on the bottom, can anyone tell me what the degree of the answer would have been if I divide that? X cubed blah 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 over x plus 1. What would the degree have been? So what I'm trying. Yeah, so if I would have changed this to just x right here, and I divide, wouldn't I end up with x squared plus blah blah blah? I need you to understand me. So
Then you could use.
hold on.
That division.
Exactly, I love it. So if instead of this, the problem had been x plus 1, we could have just used synthetic division. But my important point is, what would the degree of the answer have been?
That's squared.
X squared. I love it. So watch this. So therefore, wouldn't this piece have been x squared, blah, blah, blah? Wouldn't the asymptote be parabolic then?
Yeah.
So watch this. Okay. So if I change this to x, now of course what's going to suck is this is not true anymore, but look at the end behavior.
Parabolic.
Parabolic, yeah. Now if I did the long division, I could find out exactly what that x squared is and plot that too. But you can see visually that is definitely parabolic. Do you guys understand? Okay. So if I put in here anything, and I mean anything, so if I put in here 3x cubed minus 5x squared plus 7 over 2x squared minus 4 or 3. There you go, John. That's going to have an x, right? The answer is going to be x. The remainder is going to go to 0. So the end behavior looks linear. If I make this become first power, it's going to look, poor little dude, parabolic at the end. See that? Doesn't that look like a parabola? Okay, good.
Line right, the first one, is that the slant asymptote?
No, the slant asymptote is this, is the parabola.
Yeah.
In the middle, isn't it doing weird shit in the middle? It's doing very weird shit in the middle. In fact, can anyone help me figure out what's it doing right here? Is there a vertical asymptote here? Let me make this a little bit easier. Let me take this out of here. Ah, shit. That's all right. I think it's still going to do. Yeah. That really looks weird, but too bad for us. Let me put that back. Okay. What's happening right here? Where is the vertical asymptote? What makes the bottom 0? 3 halves. So at x equal to 3 halves, in fact, let me put this in here. That's your vertical asymptote. But what, so again, horizontal asymptote doesn't give a shit what's happening when x is small. It just cares about when x gets big. So when x gets big, if I just zoom out to this level and take this away, if only that middle thing wasn't there. The outside of it, doesn't it look parabolic? Okay. That's the idea. In fact, I could make this better. Let me see. I can make this a little better, I think. Let me see. That's looking a little better. Let's make it even better. There we go. That definitely looks parabolic, correct? In the middle, it's doing weird shit. In the middle, it's doing weird shit. I don't care. Horizontal asymptote only cares about the outside. Okay. Maybe? So, to find a slant asymptote, you do the long division. So let's do an example, all the way out. All right, let me see if I can make one that's not too evil. Shice.
Number 1 on the paper.
Say what?
Number 1 on the paper, they got your rational function paper. Actually, what's this? It was C, 1C.
What now, sir?
Talking about the handout.
Handout.
Oh, okay.
1C. I'm just trying to recall.
The handout that we did?
Yeah.
Okay.
So for C, it says y equals 3. That would mean the reason it's 3 is because it's 3 on top and then 1 on the bottom coefficient.
The important thing is, so let's do this. A little review real quick. All I care about are horizontal asymptotes. Right? All I care about is horizontal. So on this one right here.
That would be -7.
What would the horizontal asymptote be?
-7, right?
Yeah. Why?
Because that's a coefficient.
I don't care. Why is the asymptote not 0 or infinity? Why is it a constant? What situation am I in? What do I always look at?
Same degree on top of the
Same
bottom.
degrees. Good. When they're the same degree, the asymptote is the ratio of the coefficients of the highest degree terms, right? And then we looked at several reasons why that's true. So when they're the same degree, the horizontal asymptote is a nice flat line. When else is it a nice flat line? If what happens here, I don't know what my deal is with 7. I just love that 7 today. What will the horizontal asymptote be? Nope.
No.
What's the degree of the top? Degree of the top?
5 is
5th degree. What's the degree of the bottom?
6.
6th degree.
So that's
The bottom grows much faster. So I'm dividing by a number, just getting bigger. So the whole thing is going to 0. When the bottom degree is bigger, it's going to overwhelm the top. The division is eventually going to go to 0. When x is small, this thing could be whatever. You get all these wiggles in the middle, but at the outside, it's got to be going to 0. Okay. So then we get to this one. All right, let's do this on those two paper. Okay, so here comes the slant. I'm going to tell you right away it's already a slant. All right, so let's do this one together. What do you got, Jeff? I don't know. Yeah. Sure. Okay. Let me do this. Make the bottom, I want to get some vertical asymptotes in there too. So make the bottom this, yeah. Say again, sorry?
That's for 2x minus 2.
Yeah, good. So what am I, so if I factor the bottom,
Then it's negative 2 and positive.
what are my vertical asymptotes?
Positive 2, negative 2.
X equals 2 and negative 2. Yeah. Let me make one more change just to make this a little easier. I'm focusing too much on the horizontal asymptote and the vertical asymptote. I'm going to make one little change, okay? Instead of plus 1, I'm going to make this minus 6.
Then that means then what you can do is you
Can I factor the
yeah,
top?
You can factor by group.
Yes. So I'm going to do this a little. Is everybody with me? I can factor this by grouping now.
Yeah.
If I take an x squared out of here, what am I left with?
1 minus x minus 2.
And if I take a 3 out of here, I'm left with.
X minus 2.
So just to jump to the chase, it'd be x cubed plus 3 times x minus 2.
X squared.
X squared, yeah. Thank you. So what's the, all right,
And then you
let me
can
stop.
cross-
Let
cross out the-
me stop. So when you're given a problem like this, a really smart idea in the first place is to factor the top, factor the bottom, because it's going to relate to the x-intercepts, and it's going to relate to the vertical asymptotes, correct? So if it's not already factored, it's a good idea to factor it. So I wanted to make that one little change, so the top would be factorable. Okay. Vertical asymptotes, I could see that from the bottom. This comes from the bottom because if the bottom is 0, the thing freaks out. That's where it goes to infinity, negative infinity. One little thing here that's, oh boy, Jeff. All right, this is a good place to put this. What happens with these?
Eliminate.
They would cancel everywhere except at 2. Because what's 0 divided by 0?
0.
Anything divided by 0 is undefined. 0 divided by anything is 0. So somehow 0 divided by 0 is both undefined and 0. So you can't divide by 0. I don't care what's on top, you can't divide by 0. So this is a good example of, is there actually a vertical asymptote at 2 then? No. So if you ever get a situation where one part of the bottom cancels, that's going to be true everywhere except 2. So this is not going to go to infinity. So real quick, why would this possibly be the location of a vertical asymptote? If I plug numbers in that are really close to 2, doesn't this piece get really small? 2.1 minus 2 is 0.1. 2.01 minus 2 is 0.01, yes? And normally what that means is I'm dividing something divided by something that gets really, really small, so the whole thing gets really, really big. But doesn't the top have a part that gets equally small? So it actually, there ends up not being a vertical asymptote. There ends up being an open circle right there.
Negative 2 still be a vertical asymptote.
Totally. Negative 2 is fine. There's no part of the top that has an answer to the x plus 2 piece. But 2 will not be a vertical asymptote now. It'll just be an open circle there. Can we stop for a minute? So again, the reason that we have vertical asymptotes is if the bottom has, like in this case, an x minus 2, when x gets close to 2, that gets really, really small, correct? And if I'm dividing something by another thing that's getting smaller and smaller, much quicker, so see how the top is getting smaller? But the bottom is getting smaller much faster, yes? So this is 70, this is 600, this is 5,000. That is still going to infinity, correct? That would be a vertical asymptote. It would go to infinity. What's happening here is there's a piece that is going just as small as the bottom at the same time, so they would always cancel, yes? That's not going to infinity anymore. You guys with me? So whenever this piece cancels out, because I think there's at least one problem like this in the homework, you're not going to get an asymptote. You're going to get an open circle there. So can you guys take a minute? Maybe we'll do this together. How do I get the horizontal asymptote? What situation am I in for the horizontal asymptote?
It's a slant.
Why?
Because the top degree.
Top degree is bigger than the bottom?
Even in the factory.
No, it doesn't. I don't care. All that matters is the top degree is higher than the bottom. So what's the process I use to get the slant asymptote? How do I get this slant asymptote? Divide. Good. Just long divide. Okay. Now, to be really honest, if you wanted to, couple things. You could actually long divide this instead, because it's actually kind of equivalent, but let's just do this because you might not realize that. Also, you could sort of synthetically divide twice, but that gets a little bit gross when there's remainders. So I'm just going to long divide. I'm just going to kind of do this a little bit quickly. Right, change the signs. Change the signs.
That's a zero.
Hmm?
It becomes a zero since the bottom.
Yeah. So the remainder will always go to 0, because the whole idea of a horizontal asymptote is let x get big. This piece will always go to 0. So now I'm just left with this piece.
I still don't understand when you say let x get big.
Say it again.
I don't understand what you mean by let x get big. Like, or because the x value is going to be 2?
No. So horizontal asymptotes are built on the idea of what happens when x gets big. That's the idea they're built on. So when x gets really, really big, positive or negative, does my function have to approach a certain number? Does it have to go to 0? Does it go to, in this case, yes, I'm just saying in general, right? Okay. So horizontal asymptotes, that's why I can cross them a lot of times, because it doesn't matter what happens when x gets small. It just matters what happens when x is really big. Okay. So if I try to graph a bit of what I know, right? If I try to graph a bit of what I know, I've got one vertical asymptote, one real vertical asymptote. It's going to be this one. So I got an asymptote of -2. I've got a slant asymptote of x minus 2, right? So I got to graph that thing. So x minus 2, so it's got there, and then it's got a slope of 1, it's got a slope of 1, so it's going to look like this. Let me stop for a minute. And then I gave you an example like this before, but let me just show you. So what can happen here? I still have 2 regions. My vertical asymptotes are always what cuts it into regions. This could be here. That could be part of the answer. You see how it lives in that little room I set the walls up for? Or it could be here. You guys kind of with me? No, I need you. Yeah, so these walls here would define a function that does this. Is that cool? Okay. Or I could do it up here. Now what tells me it's not going to do this? Do I have an x-intercept back here? Huh?
You don't have a door.
I don't have a door. I don't have an x-intercept there. So I know it's going to look like this. Okay. In fact, I don't have any x-intercepts because the one possible x-intercept I could have canceled. Right? So I don't even have any x-intercepts. So that pretty much tells me that up here, I'm going to have to live up here. Right, so like, let me see, I moved the paper. Jeez, that's what that freaked me out. So I'll bet anything that this sucker looks like that. What's my y-intercept? What's my y-intercept? Yeah, if I let x equal 0 and these cancel out, I would get 3 halves. Is that cool? So it looks like my my y-intercept is going to be positive 3 halves. So I'll bet you anything this sucker looks like this, and it's going to do this. Yeah. So there's no x-intercepts. One little thing that you have to be careful about is what is happening at 2. 2 is where weird shit's happening. It's where I normally would have put a vertical asymptote. Am I allowed to let x equal 2? No. But I need to know where to put the open circle. So if I do let these cancel, where would this part want to be if x is 2? What do I get if x is 2 for this part here? If x is 2, what do I get here? Good. 4 plus 3 is 7. Over? 4. So at 2, oh shit. At 2, let me just go here. Let me erase this. I'm going to be moving the paper around. So, is everybody cool with it can't be here, and the only other because there's no x-intercept, so the only other option is for it to be down here. To be really sure, I could plug a -3 in and see what I get. Here, I'm pretty sure it's not going to do this because then it would need an x-intercept here, right? And there is no x-intercept. So I'm pretty sure, and we just figured out the y-intercept was 3 halves. And we just figured that at 2, it wants to be at 7/4.
Why is there no x-intercept? Reminder.
Can you make this 0 with a real number?
No, square root of 3.
I. There you go. Okay. No x-intercept. Yeah. So therefore, it's got to slam up against this wall. It's got to go through here. At 2, it's supposed to be at 7/4, which is 1 3/4. So then it's going to look like that. Now, since I tried to make one up out of nowhere, that was a little freakier than I wanted it to be. So right here, what do I really have to put? To be very specific, you got to put a little open circle. Now, real quick, I want to show you. Let me stop right there for a minute. Let's do this since some of you guys might not be able to access Desmos. Let's try to do this here. So if I put in the y equals, I put in there x cubed. What was it? Minus 2x squared plus 3x minus 6 divided by, what was it? X squared minus 4. Yeah, so you get that little, so again, comparing it, with that little thing here, and then I get this up here. You guys with me? And so there are no x-intercepts. And this has got to slam up right here. These have got to, if I just come out just a little bit, if I look down a little bit further, I can see this a little better. So there's the vertical asymptote here, at -2. This is coming down through. Now watch this. If I try to calculate a value of 2, look what it does. What's the output at 2? There isn't one, so that's an open circle, right? If I try to do any other value that I'm allowed to, like 1, it's going to give me an output.
Yeah.
If I try to do 2, of course there's no output. That's the open circle. Okay, I like it. So we know something weird is going to happen when there's a number that makes the bottom 0. In general, it's going to be a vertical asymptote, but sometimes it could be an open circle. Yeah.
That's also right, because if you plug in 2 into x squared, it's 0, you can't divide by 0.
That's the whole idea, yeah.
Yeah.
That's the whole reason, yeah. Okay. Alright. So slant asymptotes, how do you find them in general? You long divide. When do you know there's going to be a slant asymptote that exists? When the numerator power is bigger than the bottom, right? That's when there's going to be a slant asymptote. Okay. So the process for finding out what it is just the long divide. Okay. Do I have any more paper? No. I have one piece. Okay. All right. So there should be like a couple of slant asymptote problems. Off the top of my head, I can't remember if I gave you a problem that's got like an open circle or not. There could be one like that, but in general, they could happen. Okay. And again, in general, try not to graph it in your calculator too early. Try to do some work first. Only do the graph in the calculator to check it, or if you're really stuck, just to get some hints. Does that make sense? Or Desmos, whatever you want to use. Okay. All right. So get in there, try those out. Let me know if you have any questions. We're going to get into chapter 6 a little bit. And I think compared to where we just came from, I'm pretty sure most of you guys are going to appreciate chapter 6. We'll find out. The one part of it, well, we'll see. There's one part of it that people normally react poorly to when I mention it. I'm not going to mention it. So chapter 6 is all about exponentials. So what pre-calculus does, and I'm pretty sure at this point you guys can relate to this, it analyzes the hell out of graphs. Because again, when you get to calculus, you want to be able to make rough sketches very quickly. You want to know what a function kind of looks like. You want the calculus to be the only thing you worry about, and the graphs to be kind of like quick. So pre-calculus is designed to put you through the paces without a graph thing so that you can make quick sketches really quickly. You know exactly what to look for to get an idea of what it's going to look like, all that kind of stuff. So now we're going to add another function to our list of functions. So let's do this real quick. You all know what a square root looks like. Yes? What's it look like? Okay, a couple of you guys. Oh, okay, yeah. Wee-haw. What's a absolute value look like? V. I love it. Of course, parabolas are easy. They're like a U. Yeah. What else we got? Now we know what this looks like. Right? Okay. And of course we know what x cubed looks like. X to the even, x to the odd. They look like those. Okay, and that's end behavior kind of stuff, right? Okay. So we're going to add to this. The one main place we haven't shoved a variable in yet. So we put a variable in the base, like x squared. We put a variable under a root. We put a variable under a number. We put variables like everywhere. The one place we haven't put them yet, and it kind of gives it away, we haven't put them up to the power yet. So something like 2 to the x. So some of you guys know what this looks like possibly, huh?
Can you just put paper up for like 2 seconds?
Oh, sure.
Okay, thank you.
Okay, 2 to the x. So we are going to learn some new functions later, primarily trigonometric functions. This is a new function we're going to pretend like. I'm sure some of you guys have seen this before. Whenever we hit a new function, the very first thing we want to do, one of the very first things we want to do is graph the damn thing. And then the next thing we want to do is, how do I solve equations that have these crazy things in them, right? Now in general, why do we do that? Because in the real world, when I set up equations relating observations, this could show up in an equation. And I might want to know the answer because it could have to do with when is a hurricane going to hit. I know we're in California, but yeah, we almost have it.
Feels like it for us.
Yeah. So if I make a little table of values, can you guys tell me what numbers do you want to plug in?
1, -1, 1.
Yeah! So, I'm sorry, I'll calm down. You always want to plug in some negatives. You always want to try to plug in 0. Can somebody tell me real quick, is there any number I cannot raise to that power? 2 to the 0 is what?
1.
2 to the 0 is 1, correct? Okay, I love it. What's 2 to the negative 1 power? That's basically the question I've got to you right now. What's the negative power mean? Upside down. Flip it, big. Yeah. Do you guys know why, real quick? Do you guys know why a negative power means flip? No? Alright, I'm not even going to ask you if you want to know why. I'm going to tell you. Guys, real quick, help me out. What is x cubed divided by x squared? Because what do you do when you divide like bases? What do you do with the powers? Subtract, right? Because I had 3 x's, I'm losing 2 of them, so of course I'm going to subtract to see how many I have left. What's x squared divided by x squared then? X to the 0. But like you also said, anything divided by itself is 1. The one number that doesn't work for is 0. It's not 0's fault, poor little 0. Always make him the villain. Now, if I want to figure out what a negative power means.
Wait, where are you getting x over x squared?
Say again, sorry?
Where are you getting x over x, or x cubed over x squared?
Oh, this is just examples.
Oh,
Sorry.
okay.
Yeah. So I'm investigating what powers mean, right?
Okay.
So one way to investigate what a 0 power means is to set up a situation that would result in a 0 power, and then see is there another way to look at it. Sure enough, I can make a 0 power by making like bases of the same exponent, and of course that would be 1 for most numbers. How do I investigate a negative power? So if I put a squared on top, what would I put on the bottom to end up with negative 1 power? 3. Now, help me out. How many x's are on the top? That's crazy. How many on the bottom?
3.
How many cancel? How many are left? 1. Where? On the bottom. So what's the negative power mean? Flip. That's all a negative power means is flip. That's all it does. If you're on the bottom, you come up. If you're on the top, you go down. So what is 2 to the negative 1 power? 1/2. Kick ass. What's 2 to the 0 power? 1. What's 2 to the first power?
2.
Yeah, okay.
Do that one.
So then if I go to graph this thing, so at negative 1, it's 1/2. At 0, it's 1. At 1, it's 2. Now, real quick, what's going to happen if I let x get really, really big? 2 to the 4th, 2 to the 5th, 2 to the 6th. It's going to get big quick, right? If I keep doubling, it's going to get big quick, right? It's going to quickly. It's going to fast upslope. So this is just going to go like this in this direction. It's not asymptotic. There's no reason there would be an asymptote there because I can plug in 7 and get a number, right? So it's just, but it's going to go quickly up. You guys agree with me? Have you ever heard the thing about would you rather get $5 million right now or I give you a penny and then I give you double that tomorrow and double that the next day for the next 30 days? You would much rather take the penny because you'll end up with more money. We just don't understand how quickly doubling grows. Right? If any of you take biology, you understand how quickly doubling has some bacteria. What if you did? And you're like, holy shit, shouldn't leave that out. What's happening back here though? Well, let's see. What if I put in negative 2? What do I get? What's 2 to the negative 2? What's 2 squared? What's 2 squared? 4. So what's 2 to the negative 2? 1/4. I love it. So negative 3. 1/8. I love it. What about negative 100? That would be 1/2 to the 100. Is that cool? The only way a fraction can be 0 is if the top is 0. Do you all agree with me that if I put negative powers in, it'll be 2 to a negative power, which becomes 1/, yes? So can the top ever be 0 then? Can this answer ever be 0 then? No. But what is 1/2 to the 100th? Can somebody tell me something about that number?
To Google?
No, it's 1/that.
Sorry, what was the question?
1/2 to the 100th power. I don't want to know what it is, but can you tell me something about it? Is it big?
It's super tiny.
Super tiny. 1 divided by freaking huge is super tiny. And I could just let this keep going 1,000, 1,000,000, 1,000,000,000, 1,000,000,000, blah, 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 right? So what's happening at the x-axis then? Could it ever cross the x-axis? Could it ever be 0? No, because the top's always going to be 1, right? So what's happening there, of course, is horizontal asymptote. So this is the shape. The shape is true for any a to the x. So if I change the base, if I made this 3, that would have been at 3, correct? 3 to the first power would be 3, and this would be 1/3. It would still have the same shape, it would just kind of go up faster. And of course, if I triple something instead of double something, it's going to increase quicker, right? So that part makes sense. I like it. But they all have that same shape, the same shape. So one thing I could do is I could take the shape and I can move it around. If I wanted to move this shape back 1, what would I do? So if I wanted to set up a function that would take this shape and move it back 1, you guys can do this. What would I do? Say again? Where? Where would I put a +1? I want it to move left and right, so I'm going to put +1 next to what letter? X. I love it. So if I have this function here, that would be a shift left 1. Transformations do not give the first shift what function they're in. They always have the same effect. So if I see an x plus 1 instead of an x, that's going to take this shape and it's going to move it back 1. Is this cool? How would I move the whole thing down 3? I want to take this whole thing and move it down 3. What would I do to the function?
X minus 3.
No. That would move it right 3. I want to move it down 3.
Y minus?
Minus 3. This would be left 1, down 3. Are you guys with me? Nothing's changed in terms of transformations. They always do the same thing. That piece is cool. The function changes. Transformations don't care. Whatever the shape is, you move the damn thing. Real quick. Where's the asymptote on f of x? Where's the horizontal asymptote here? Where is it? What is it?
Y is equal to 0.
Y equals 0. Kick ass. Right? Where would the horizontal asymptote be for this guy?
Y is equal to -3.
Yeah, I just moved everything down 3, so it'll go to -3. Real quick, how long is the horizontal asymptote? How long is it?
Forever.
Forever. So if I move it left to right, does it change where it is?
No.
Nope. It's only if I move it up and down. So I know exactly where the horizontal asymptote's going to move based on how much I move that sucker up and down. You guys kind of with me? So sort of like parabolas, vertex is huge, up and down opening is huge. For exponentials, where is the asymptote is like the biggest thing, the most important thing to figure out, because you already know what the shape's going to be. You just got to figure out where the asymptote's going to be, right? Okay. Yeah, that's enough. We'll stop there. Okay. So if you didn't get your grade sheet, just come up and see me. After Tuesday's test, I'll have an updated summary sheet for you. If you have any questions, come see me. Otherwise, I'll see you tomorrow. Yeah.
So in that specific problem, the vertical asymptote would be 2 because that's where
There's no vertical asymptote.
it just keeps going up.
Because I can make x as big as I want to be. If you put a vertical asymptote, you're saying either there's an x that doesn't work, we already said every x works, or you're saying that there's a maximum x that you can get to. And of course, you can make x as big as you want to be. The only asymptote it has is a horizontal one. Yeah. They'll be a little late, but I mean, they'll definitely count more than nothing.
Okay,
Yeah.
alright, is this configurator, that's configurator for you?
Yeah, they're all turned in and okay, so these will be a little late, so it'll be a little less than this, but it's gonna be a lot closer to that. Yeah.
Percent. I feel like it, but,
Alright,
let's see, I'll tell my grade is on this test.
alright.
Yes. I just I'm just curious how this question goes.
Oh, the whole idea here is it's the difference of cubes.
Uh,
So this would be 2 times x minus 5, this would be y squared times this, and then you put one of each. It's just a lot of parts. But so you're gonna have a giant little dude and a crazy big dude,
Yeah.
right? Does that make sense?
yeah, that makes sense.
So yeah, the key there was realizing it's already cubed. So a lot of people are multiplying shit out, and that's the opposite of what we need to do.
Yeah.
Okay.
All right, thanks.
You're welcome. Oh no. There you go. So I changed that because I just had put the wrong. Everything else is right though. Cool.
I appreciate it.
So let me know if you have questions.
I have a couple questions. I was confused. Why are we long dividing to find the slant? Can you explain?
Oh, okay.